graphing review and talk about these graphs, okay? And one thing you have to be careful about is look at the type of graph we're looking at. So first of all, we're going to try to identify these with just a group of words. So first of all, how is it moving? Is it moving forward, moving backward, or not moving? Now remember, moving forward, if we draw our little compass again, moving forward is going to be in a positive direction. Moving backward is going to be a negative direction, okay? And is it speeding up, slowing down, or constant speed? So these are groups. This is group 1, moving forward, moving backward, not moving. Group 2, speeding up, slowing down, or constant speed, okay? So we're going to look at each of these. So the first one, number 1, this is a position versus time graph. You can see that there's an X here, position versus time, okay? So we're going to try to capture the words that go with this, okay? So if this is going from a high X, okay, a positive X, to basically to 0, okay? So this guy is, and I'm going to write it, it's moving backward. Okay, now the question is it, so how is it moving? Well, this has a constant slope. This is a position versus time graph. It's a diagonal. It's got a constant slope, and it's negative, right? It's negative, so it's moving backward. Well, it's got a constant slope, so that means the slope of a position time graph is the velocity or the speed. So this has a constant speed. Okay? Okay, let's go to number 2. Well, this is also a position time graph. This is positive, this is 0. Okay, you notice this has a gentle slope here and a steep slope here. So it's changing position slowly here and faster here. So if it's changing position faster, that means its velocity is increasing. But which way is it going? Well, it's moving backward. Well, because it's going from a high X, positive high X, to a lower X. So it's moving backward. It's moving in a backward direction. Okay, it's moving in a negative direction. Okay, it's moving backward. Now, is it moving at a constant speed? Well, the slope of this position time graph, is the velocity. Well, this velocity, this is a slow velocity, and this is a fast velocity. So it's speeding up. Okay, so now we'll go to the third one. Okay, this is another curve. Okay, again, and this is a position time graph. So this is fast, steep slope, moving forward, gentle slope. Okay, so one thing we can say right off the bat is this is moving forward. It's moving from the origin, from 0, out to some positive X, some positive position. So it's moving forward, moving in a positive direction, forward over here, right? And we know it's going fast initially, and then it's going slower, so it's slowing down. The slope is getting gentler. It's going from fast, steep, to gentle, slow, slowing down. So I'm using these words up here, okay, these groups. Okay, so let's go to this one. This is a really strange one. So this starts at a higher X at time 0. And then as time goes on, it moves backward towards 0, okay? So this thing's moving backwards. Okay, there we go. It's moving backward. And you notice it's steep, so it's fast initially. And then it's gentle late, so it's slow. So guess what? Fast to slow, it's slowing down. So it's moving backward and it's slowing down. Okay, so let's go to this one. This is a velocity time graph. You notice these aren't the same. These are all 1 through 4, all positions. This is a velocity time graph. Okay, well, this shows kind of an increasing velocity increasing at a constant rate. Okay, so, and it's positive. Okay, so here, you know, you're moving in a, you've got a positive velocity, right? So you're moving forward. Okay, you got a positive velocity moving forward, and your velocity is increasing, so you're speeding up. My writing's bad, but try to make the best of this here, huh? Okay, next one, number 6. Well, you start off at a high velocity. This is another velocity time graph. You start off at a high velocity. Okay, you end up at basically at rest, and you notice the velocity decreases at a constant rate. Okay, so your velocity is negative, right? Or sorry, your slope is negative. Okay, so you're slowing down. Or sorry, I'm going to say this correct. Yeah, you're slowing down because your velocity is slowing. But do you notice your velocity is positive, right? All the time. It starts off very positive. It ends up being lower positives, but it's always positive. So this thing is still moving forward, even though the slope is the other direction. Okay? It's moving forward, but it's slowing down. So it has a negative acceleration, actually. Okay, so let's go on. Okay, last group. This is a velocity time graph. So this has got a velocity equal to 0. Okay, so it's at rest. It's not moving. Okay, this has got a velocity which is negative but constant. Okay, negative but constant. So it's moving backward. Okay, it's moving backward, but it's moving at a constant speed. And then the last one, hey, notice this is an acceleration time graph. Okay, so we're going to go back up and say, well, is it moving forward, backward, or not moving? Okay, well, you can't. Who knows? You know, you can't really say a lot, except you can say one thing about this. You can't really say which direction it's moving. But you know one thing, it's accelerating in a positive direction. So it's, you know, it has to be either speeding up. No, I'm going to say that differently. I'm going to say, you know that you can't really say a whole lot, except you can say you have a positive acceleration, and that acceleration is constant. But you don't really know what direction you're really traveling, okay? You don't really know that, okay? And you don't even know that you're speeding up, okay? Okay, next one. So on a position versus time graph, what does the steeper slope mean in terms of speed? Well, a steeper slope means greater velocity or greater speed. Because it means on a position versus time graph, if the slope is steeper, that means the velocity is greater. The velocity or the speed is greater, okay? That means a greater velocity or speed, okay? So what does a curve on a position versus time graph tell you? Well, if it's curved, that means the slope is changing. And if the slope is changing, that means that if it's curved, that means the velocity is changing. Okay? So how do you try the average velocity from a position versus time graph? Okay, so if you have a position versus time graph, I'll show you one, like this one, okay? Okay, you find the average velocity from a position versus time graph by looking at the slope of the graph. How do you find the average acceleration from a velocity versus time graph? Well, same thing. You look at the slope. Okay, let's take a look at that. For example, here, how do you find the average acceleration for velocity versus time graph? Well, let's look. Here, you have a constant velocity, so that means no acceleration. Here, you have a changing velocity, so this means you have the slope of this is your acceleration. Okay, the slope of this is your acceleration. Okay, okay. So how do you find the displacement from a velocity time graph? Well, you look from a velocity time graph to find the displacement, you look at the area under the graph. We did that last week. Okay. We did that last week. And then the last one, how do we find the velocity from the acceleration versus time graph? Well, again, same thing. It's the area under the graph. Okay, I'll let you go. Bye.